All right, welcome back. Those on YouTube, those on Twitch, you're still here and you haven't missed anything. Let's go to the next room, IAM Principals. An overview of the different types of actors in IAM. IAM Identities, sometimes referred to as IAM Principals, provide access to an AWS account and its resources. These principals typically provide for authentication or validated authentication was performed. Principals are a core concept for resource policies that are attached to resources like an S3 bucket and define who is allowed to act on the resource. This room will explain the multiple types of IAM principals and their significance for attack and defense tactics. Let's get started. Let's do it. Hey, we get to spin up an environment. I've not done this, guys. This is my first time doing this. So we get to spin up our environment. It's like the cloud details button at the top of the room. I need to actually see what this is going to pop up because I may have to stop sharing my screen because if this gives like credentials, those of you on stream could technically access the environment. So let me just see what all happens. Where needed, generate the environment required for the room. The generate environment button will appear if the room contains an environment that needs to be generated. For any issue with the environment, select the reset environment button. Review this article for more info. To view the creds required for the environment, select the Credentials tab. You can use these credentials to access the environment in various ways. More information can be found here. Actually, I don't even care, guys. If you really take the time to log into this while I'm live on stream, screw it, be my guest. It's not my AWS environment. And TryHackMe told me no restrictions on what I stream. So I don't know what's going to pop up. Please don't hack it if you do. Oh, well. Okay, hold. What do I need to do? Do I need to actually spawn one? Generate an environment or set up your credentials. Okay, so cloud details. Generate environment. Hooray, environment generation is in progress. Do I like monitor it? Okay, so we have some credentials there. Like normally you don't want to share this stuff live on stream, but it's not my environment. Can I open this? Okay. Cool, so there's our username. Let's just see if we can log in. Well, this would be the default console password. That's what we want. Oh no, username. Here's our username there. Okay, and we are logged into what appears to be our environment. Cool. Let's keep going. IAM Users. I can even get out of this F11. IAM Users are the most basic form of an IAM principal. They represent a person or application. IAM Users exist in a single AWS account, and AWS acts as both the authentication and identity store for IAM users. Take a look at the users that exist in your TryHackMe account via this AWS console leak, and let's collect this. We'll throw that to the side. We'll throw this to the side, and then we can see both of these. So if we want to see IAM, we can just start typing IAM up here. And it appears we have two users. There we go. TryHackMe IAM user and those two. IAM users can have both a login profile and up to 2 access keys. The login profile is a password that can grant access to the AWS Web Console. Access keys are AWS generated and consist of a key ID and a secret. So if we see this one, like if we click this, we have a console password. I don't think we have. No, we do have access keys too. All right. Cool. And here's the AWS CLI. IAM users, which is just listing it. Do we have that? Do I need to, I wonder if I need the attack box. I have my own VM. Actually, here I have Kali configured. We can use this as well. I have AWS CLI and everything installed on here for when I do CloudGoat. So we'll just get this ready in case we need to use it. But we'll try this as well. I'll make this full screen and then I'll get out of the attack box in a second, but we just have to let it load. Oh, can I exit split view? Sweet. We'll just let it load in the background. And here is using the AWS CLI. Oh, sweet. Hold up. What's that do now? Cloud details. You have access to an environment for the following rooms. Introduction to AWS IAM, IAM Principals, blah, blah, blah. Okay, cool. We have our environment now. So in the AWS CLI, we could do AWS IAM list users, and it will list the users that are available in our account. We can do AWS IAM list access keys for username Chris. That will tell us, hey, here are the active access keys that have been generated for the username Chris. It's not going to give the secret. When you generate an access key, it only gives a secret one time. IAM users are the most common way that AWS accounts are compromised, usually due to careless handling of the IAM access keys generated. They're often committed to GitHub, live streamed on Twitch, stored in config files insecurely, or shared via insecure means. There are 2 IAM users in your account. The one you're using is a 12-digit account ID. What is the name of the other user? It is TryHackMe IAM user. An IAM role is an AWS principal intended to be assumed by a person, service, or resource. For example, an EC2 instance might require permissions to S3. With AWS IAM, an EC2 instance is permitted to assume a specific role that has access to S3. Roles are also used when larger orgs use an external identity provider to access AWS. Roles are also required when AWS itself wants to take action on your account. Take a look at the roles in your TryHackMe account via this AWS console link. We can just click roles. And you can see our different roles here. We have our TryHackMe IAM role. I'm guessing that's the one we're going to be talking about. We have invoke event. That must be Lambda, budget Lambda execution role. Okay. IAM roles have what is known as an assumed role trust policy. So can I click one? Trust relationships, and here's what it's talking about. This trust policy specifies what principals are permitted to assume a role. Click any of the roles in your account and check the trust relationship tab, which is what we did. So we have the effect allow, and we have the federated role here, assume role with SAML. In this screenshot, so here's the one it's talking about, we can see the role that can be assumed via the line effect allow by the AWS service support Amazon AWS. You can also see the same information by listing the roles in the AWS CLI. Now here's one problem. Can I do it this way? I've never actually used Cloud Shell. Beautiful. So we can do it that way. And that's showing our different roles that we have here, and we're just following that. So if we look at this, let's see if we can read these. So we have this role. Here's the path. We have the role name, the role ID, the ARN, remember the unique identifier, the create date, the assume role policy document. That's where we have it's allowed for this service to assume a role. And then we have a description, enables resources, blah, blah. We have another role name of teacher, and we have the ARN here. It allows root. Okay, so it must allow the root user, assume role to check in on students. The IAM Service API call assume role is the operation that leverages this trust policy. We'll discuss how that is used and how you can leverage that in an attack scenario in the room discussing AWS creds. There are several roles in your account. What is the trusted entity for the organization account access role? Okay. Organization account access role. I think it's looking for this right here. Root user in the AWS account. A root user is a special form of IAM principal meant to represent the account's owner. Root users have full privileges in the account, subject to any service control policies, which we will discuss later. The username for the root user in AWS is always the email address used to create the account. You will rarely encounter the root user in day-to-day AWS deployment. As the defender, you want to ensure that the root mailboxes for all your AWS accounts are monitored. Amazon will send critical security and operational notices for each account to its root email address. As an attacker, if you get access to the email box of the root user, you can potentially reset the password and take control of the AWS account. Boom. We'll show you how the password reset process works in a future room. Fun fact, before 2017, AWS accounts and Amazon retail accounts that shared the same email address were linked. This created what is known as the underwear problem, where a startup's AWS account was the same account the founder used to buy underwear. This is important because full access to the account may also be shared if an Amazon or retail password is shared amongst people. AWS recommends you do not use the root user account for day-to-day activities. You should always use an IAM user role. The root user is necessary for a few operations that are documented here, right? They're drilling this into our brain, right? That's like, if there was a test at the end of the day, the teacher would be like, hey, this is going to be in the test. It's not possible as an IAM user to identify the root email address of the account you're in. However, if the AWS account is a member of an AWS org, you can discover the email address of the organization's master account. Try it with this command. All right. I not paste. Okay. Whatever. Oh, I can't type. Jeez. It's broken. I can't, guys, I'm typing right now. Try new terminal. There we go. I don't know why I broke the last one. AWS organizations, describe organization. All right, and there's our master account email, awssecurity.labs@tryhackme.com. What is the master account email? It is this guy right here. So, of course, if we get compromised that account, we could take over the root user. IAM Groups. IAM Groups are collections of IAM users. Groups are useful in that you can apply policies to the group and users in the group would inherit the permissions. Only granting permissions via IAM Groups is considered a best practice in many circles. You can see the IAM Groups in your account via the AWS console here. Throughout your TryHackMe AWS journey, your IAM user will be granted the proper permissions for the room you're using. This will be done by adding your IAM user to an IAM group that matches the room you're in. So let's use the terminal. Can I make this bigger? Whoops. So it's easier to see for those of you on stream. And right now we have just two groups, our IAM module group and our TryHackMe IAM group. Bottleneck said, what programming language is this? It's just AWS CLI. It's not really a programming language, but it's very verbose when you're trying to do things. I have a whole cheat sheet I made in my own OneNote when I was working through CloudGoat scenarios. If I'm wrong about that, someone smarter than me correct it. Like I said, y'all, I'm still a noob to AWS, but I just call it AWS CLI language. Only granting blah blah. You can see the IAM groups blah blah throughout your. Okay, we already read all that. Technically, IAM groups are not principals because they're only a grouping of privileges, not an actual authenticated identity. What is the name of the IAM group your IAM user is currently a member of? Well, I'd assume this one. Looks like YAML. Actually, I think you are correct. It is YAML as well. Like the output and stuff. And I suppose this probably as well. Okay, AWS Services. From an API and IAM perspective, AWS has several services. These services do not always align with how they appear in the AWS console or the marketing names used. Of course they don't. For example, AWS VPC, their software-defined network construct, is part of the EC2 namespace. The call to create a VPC is EC2 create VPC and not VPC create VPC. Amazon CloudWatch is a combination of several services, including CloudWatch events, CloudWatch metrics, CloudWatch logs. Because of the AWS 2 pizza team organizational structure, there is not consistency between services around how API calls are named. Some services use get for describing resources, while others use describe. The AWS Python SDK Boto 3 documentation, which is how you can interact programmatically with this with Python, is an excellent source for understanding the AWS API service calls. From the perspective of IAM principles, AWS services can act on resources in your account. Often, a service like Lambda or EC2 will need to assume a role for your application to access resources. In the context of AWS IAM, services are always in the form of servicename.amazonaws.com. AWS services are often represented in the assume role trust policies of IAM roles. What AWS service is trusted to assume the role, AWS service role for CloudFormation Stack Sets org member. I love it. Okay, AWS service role for CloudFormation Stack Sets org member. What AWS service? So if we look at trust relationships, I think this is what it's looking for. The member org stack sex, whatever. Everyone, there is a unique principle wildcard. This is a big thing to pay attention to, which represents everyone. Depending on the AWS service, the everyone principle could mean anyone on the internet or any AWS customer. The everyone principle is how resources are made public either on purpose or by accident. The everyone principle is typically used in AWS resource policies, which we will discuss in a future room. Just agree, you're going to do your best not to win a bucket negligence award. I will do my best. Federated identities. Most companies in AWS have adopted a multi-account strategy. AWS accounts are created according to application, team, or environment. Each employee having multiple IAM users becomes an untenable situation. Most enterprises leverage a centralized identity store like AD and SAML authentication service or OpenID to grant employees access to assume a specific IAM role in specific accounts they are authorized to access. An identity provider is created with a SAML metadata document. Once authenticated by the corporate identity system, a SAML assertion document is passed to AWS. This assertion lists the AWS accounts and AWS roles a user is permitted to assume. Okay, so we have this. Our user logs into the portal, and our user is authenticated. We receive a response, a SAML assertion. We post a SAML assertion to sign in. We receive temporary credentials from that STS thing, kind of like a GWT token. We're redirected to AWS Management Console. With federated access, the authentication system provides a multi-factor authentication. Federated access requires that one or more IAM roles trust a SAML identity provider created in your account. If you look at the TryHackMe IAM role in your account, which let's look at that. We have this allow. Our principal is this federated principal right here, and it's this SAML provider. I think that's what it's looking at. You'll see the trust relationship is a sample SAML provider in your account. Yep. What is the name of the sample SAML provider in your account? It's just this. Yep. Conclusion. Now that we have defined the various actors in the AWS IAM space, the next room, IAM permissions, will go into how these actors are authorized to operate on cloud resources as we dive into the structure of an IAM policy statement. Boom. We have completed another room, the IAM Principals room. And for those of you watching on YouTube, even those of you watching on Twitch, guys, I might call it a night for tonight. I've been talking basically nonstop now for an hour and almost 45 minutes, and I can only talk so long. So guys, my plan is to probably do this almost every night as we work our way through this. I might take a few nights off, we'll see. But my plan, as long as all goes well, is I'll be back tomorrow night, same time, and starting at 9 p.m. Central Time, and we'll just keep working through this learning pathway. Just by way of review, let's see everything that we've covered in our first evening hanging out together. If we go here, our learning paths, attacking and defending AWS, we got 20% of the way done. We covered AWS Cloud 101, AWS Basic Concepts, Introduction AWS IAM, and IAM Principles. And tomorrow night, we will dive into IAM Permissions. And like I said, I have a month to do this. My plan, guys, is we're going to make it through all of this. I hope. That's my goal. That's my plan. So for those of you who hung out with me for the past hour and 40 minutes, thank you for joining. For those who maybe joined late, maybe you just got to the party now, you're like, oh, dude's already done. I'll drop my YouTube link one more time. All of my streams, I'll get posted up on YouTube. I'll probably get those posted tomorrow, and you'll be able to follow along on YouTube if you miss one of the live streams. So guys, thank you for hanging out, and I will catch you guys tomorrow night. Peace.